Giving you that heads up. I will be fine. I'm just a little bit out of it. So, reviewing over that, this is all we did yesterday. Don't worry about trying to copy this quite yet, honey. You'll see it up here when I do the practice problems. We categorized them yesterday. We put them into every section that they fall into. So if we see a fraction that can't be simplified, we know every single one of these numbers are what? Real. But if we see a fraction we can't simplify, it's automatically rational. So which means we knew this first one was rational, this fourth one was rational, and we knew that these second to last two right here were rational because they stayed fractions. Which means if they're rational and they are fractions, can they ever be integer, whole, or natural? No. And if they're rational, can they ever be irrational at the same time? No. So we know this one is continuing on forever because what's behind it? Those dots. And we see that it's not repeating anywhere, right? Irrational immediately. And once you mark this, it can't be anything else. It's real, it's this, and that's that. Make sense? We didn't have very many examples of that happening, so I'm going to give you an example right here, okay? So, let's write this one in. This one's a Miss Lipsey example. That way that Jordan can see it. So, how about negative 16, over negative 4? Negative 16 over negative 4. Do I need to type that into the calculator? Mm-hmm. All right, get that typed in. Don't say it out loud. Give everybody a chance, okay? Get that typed in. All right, what'd y'all get? Just 4. So, what categories does 4 go into? Whole, rational, real, integer. Because can you count to 4? So the thing is, if it exists here, does it automatically exist here? And if it exists in these two, does it automatically exist in this one? Yeah, they build off of each other. So if you can count it, it's there, but it's also there. Does that make sense? I know, baby, that's the printer thing. I can't do much about it. All I can do is one of these, because if I click it off, my computer won't print anything. But that's how it works. It builds off of each other. So it's everything except irrational. Does that make sense? Any questions? How can 4 be written as a fraction? 4 over 1. There we go. Any questions there? Okay. Jumping back into that example I asked you to do yesterday. I told you to just do this one piece. We're supposed to determine if it's always true, sometimes true, or never true. The sum of two rational numbers is irrational. The sum of two rational numbers is irrational. So we're saying this is sometimes, always, or never true. So, what do y'all think based on what you did? So I heard never. What was your proof behind it? Annabelle, what did you say? So you said never two. Okay. What was your example behind it?
I 6 plus 6.
You said 6 plus 6. Got you 12, right? 12 is rational, so that checks out. Would there ever be a counter example when it comes to this? But if you can provide a counter example, that means it is sometimes true. Does that make sense? You're trying to say that two rational numbers become irrational. Will that ever happen?
No.
No, because if you're adding them, it should stay the same always. Does that make sense? So, if we're looking at this, I know the biggest question is, Ms. Lipsey, what about the decimals and this and that? The decimals, even if I said 5 plus 1.3 repeating, that's still going to be 6.3 repeating. That's still rational. So y'all are absolutely correct. This will never be true. Any questions there? The only time something between a rational and another rational become irrational is if we're doing a subtraction or something like that, but if it comes through with doing common roots and all that other thing, that breaches into algebra 2. So in our case, this will never be true. Thank you for providing that example of 6 plus 6. That works. But even if you made it more complex, it still works. So I'm going to put down 6 plus 6 as well. Both of these are still rational. Oh, I also want to add the letters onto y'all's thing. So flip back to the front page for me real quick. I gave y'all letters to tell you what goes where when you're categorizing things. With rational, it's a Q for quotient. For irrational, it's an I. You can write these in, Jordan, because these weren't on the initial video. For integers, it's a Z. We're not getting into it. That's more complex than I'm willing to talk about in any algebra class. Whole is W. And natural is N. So, rational is Q. Irrational is I. Integers is Z. Whole numbers is W. Natural numbers is N. And for real numbers, it's a double-sided R. So you draw two lines next to each other, like that. And then you make an R on the farthest one. So you draw two lines, make an R on the farthest one. Any questions here? Everybody good? Jordan, is this coming together okay? Y'all talked about real numbers at the middle school, but I'm just adding more facts behind it. Okay? So, looking right here, look at this top section for me, okay? Between 1 and 30. I'm going to tell you which ones I want you to do. If you see this R right here, mark that out, put Q. I don't know why we would put a double R there. It would just be kind of confusing. So Q is for rational, real, irrational, whole, natural. And I'm also going to put the Z here because that's also missing. So put your Z there. It says name all the sets of real numbers to which each number belongs. I want you to do 1, 2, 3, 4, and 5. So just that top row. So name all the sets. You're doing it just like that one, okay? Do this for me. Make sure you circle the ones, 1 through 5. Sir. I's on irrational. Baby, yeah, it's just I. So you see how I have an I right there for irrational? You would just put I. I'm going to flip this over because Jordan doesn't have this. So Jordan, try your best on this to see how you do. Yes, sir. So you remember how we did this? This is what you're doing, except you're just writing out the letters. Guys, it's the exact same thing as this. It's exactly the same. Okay? Sir. I want you to try these practice problems to see what you know based off what's written up here. Because this is something that's already been talked about in a previous class. I just want to see what you caught on and what you don't and don't know. If you have it, you can bring it to me. Yeah, that would be great. And tell him which problems to do. Lean up for me, Gavin. Not Gavin, Kylan. Gavin's on that side. If you're tired, you already know, grab a clipboard. Let's talk about this. This was a rough group of questions for the fact that we didn't read those directions all the way. It says name how many sets? What does that say? All of them. What should have been the first thing you put on all 5 of these? Real. So shouldn't there have been a double-sided R for all of these? Because every number we talk about in here is going to be a what kind of number? So, looking right here, 30. Real, is it rational or irrational? Because can we write 30 as a fraction? By putting it over what? That's where that Q came in. Is 30 an integer? Yes, because don't integers have positive and negative whole numbers? So there's supposed to be a Z right there. That's why I told you to put the Z. Z means integer. Then, is it anything else? Because it's a whole. And can you count to it? So that makes it natural. That's how you classify that in all of its sets. Does that make sense? Look at number 2, using the same logic. We said it was real already. Is it rational or irrational? So we need a Q, correct? Does it fall into any other sets? Yes. What's another one it falls into? Integers, because isn't that a negative whole number? Can it fall into anything else? No, because it's what? Negative. For it to be whole or natural, it has to be positive. Any questions there? Do you see where the mistake was for this one? We're okay. Looking at number 3. We said it's real. It's also what? Which one? Rational. Because don't we see a fraction next to it? Can it be anything else? No, because it's also a what? We just said it has a... Can integers, whole, or natural numbers have decimals or fractions?
No.
Then that's where it would stop. That's it. 4. We already said it's real. Is it rational or irrational? Because that's a non-perfect square. It works just like that square root of 2. If you were to type it in, it would give you a decimal that went off the calculator that did not repeat. So, there needs to be an I, correct? I for irrational, not integer. Okay? I for irrational. And finally, 5. How does 0 classify? What sets is it in, other than real numbers? It's rational. So there's a Q. It's an integer. And whole. Is everybody okay? Do we want to try to redeem ourselves again? All right. Do me a favor. Do these problems that I give you. Do 6 through 10 and bring it to me. Do 6 through 10 and then bring it to me, okay? Now that you have those examples, it might make it a little bit easier, okay? Absolutely. I should type these into the calculator if I'm unsure. I should type them in if I don't know something. So we need to type in this first one, right? So in our calculator, we need to hit the white button at the bottom for negative. Second, x squared, 9. So typing that in, that's how it should look in your calculator. What'd you end up getting when you type that in? A negative 3. So I'm not focused on that. I'm focused on this number, correct? So all these numbers are what? Real. So shouldn't there be a double-sided R right there? So what else does negative 3 go into? Integers, but what before that? Rational. You see how I'm going down the list? I'm going from the highest one and going down as low as I can. That's what I'm trying to get y'all to see and do. That way you're not skipping around saying, does it go here, does it go there? What goes next? If there is something to go next. What else could it fit into? Integers, which is Z. Any questions there? Can it be whole?
No.
Why not?
Positive.
It has to be positive, and this is negative. Absolutely correct. Looking at the next one, should I type that in? Yep, so type in 6 divided by 3.
2.
So we should be looking at 2, correct?
Yes.
All these numbers are what? Real, so should have an R. Then, rational, because it's written as a fraction. Then, integer, because that's a positive whole number. Then, because it's a positive whole number. Then, because can you count to 2? So you should have 5 letters there. Any questions? Make sure you're leaning up, paying attention, especially you, Jordan. You weren't here yesterday. Lean up, pay attention. When you miss a day, you know you're teaching yourself the lesson. I'm just coming in and helping where I can. That's the hard part. The videos are there for a reason, but if you're physically in class, your undivided attention should be up here. Looking at 8, all numbers are what? Real. Not all numbers are positive. All numbers we're talking about here are real, right? So there should be an R there. Then, rational, because isn't that a repeating decimal? Can it go anywhere else? No, because integers, whole, and natural all have to be whole numbers. Any questions there? Looking at 9, should I check to see if this can simplify in the calculator? So type in 36 divided by 12. What'd y'all end up getting? So we should be looking at 3. All these numbers are what? Real, then rational, then integer, then and then. Yes, ma'am. Thank you. Y'all have been messing me up. Thank you so much. I've been seeing a lot of I's and I'm like, let's not do that. I for irrational, Z for integer. That's the best way to do that one, okay? Any questions here? Thank you, Annabelle. I needed that. Look, I for irrational, yes. That's supposed to be Z as well. Thank you. Told y'all, I'm out of it today. We saying the right words, but sometimes we don't write the right ones, and that's okay. But are we supposed to be leaning over? Your body language is 95% of what you speak. If your body says one thing, your mouth ain't got to say anything else. Okay? Make a good impression. Lean up, gentlemen. Y'all forget this is also recorded. This is going live this evening. So people saying people's names saying like Kingston, Zatarian, why are you leaning over? That's documentation. Don't shoot yourself in the foot. That's a nice way to put it. Because if a parent asks me, have you done this before? Go check those videos from the last 2 weeks. Because I record in your kids' class. That's irrefutable evidence right there. And usually these videos either make or break a kid's argument. And usually it breaks it. That makes sense? Don't do it to yourself. Let's look at this last one. Look at 10. Negative 36 over 12. Should I put that in the calculator? Yeah.
It's the same one you just did. It's backwards.
Not backwards. It just put a negative. But if you're unsure, should you type it in anyway?
Yes.
Absolutely. That's what the calculator's there for. It's to give you support. So what'd you end up getting when you typed it in? Negative 3. Real. Rational. And an integer. Can it be anything else? Because it's what? There you go. Any questions there? Does that make more sense? Okay. Y'all's job is to finish these practice problems. They model the exact same way. Okay? So get that going. Work on that for the remainder of the block. Jordan, I would recommend getting your computer out and logging in to go to Schoology. That way you can fill in the notes from the beginning.